So what we're going to do today is talk about the probabilities of being dealt particular starting hands in Texas Hold'em. If you're only dealt 2 cards in the beginning, then what probably would be the best possible scenario if you're dealt 2 cards? 2 of a kind, yeah, a pair. And what would the best pair possible be if you're being dealt 2 cards? 2 aces. Aces beat kings. A pair of aces is higher than a pair of kings. So therefore, the best possible starting hand in Texas Hold'em poker is ace-ace. If you look down and you're playing Texas Hold'em and you see 2 aces, you get excited because that's the best possible scenario. Don't do what you did. People sometimes overplay their ace-ace. It is a great hand to start off with, but if it's played inappropriately, you stand to lose a lot. So just because you have it doesn't mean you're automatically going to win. The next highest pair, we would call it if you're dealt a pair and nobody knows that you have it, we call it a pocket pair, like you got a pair in your pocket. The next highest pair after aces would be kings, and then queens, and then jacks, and then tens, and then all the way down to a pair of 2s being the lowest possible pocket pair. What you see on this chart is king-king plus. What that means is, what is the probability, what we're going to be doing eventually is, what is the probability of me being dealt a pair of kings or higher? That's what the plus means. A pair of queens or higher. So I could be dealt a pair of queens, or a pair of kings, or a pair of aces. A pair of jacks or higher, meaning, can I get a pair of jacks, or queens, or kings, or aces? And we'll see how the probability changes as we calculate each of those. Just before we do any math, conceptually, do you think the probability of you being dealt a pair will increase or decrease if we add more pairs to the acceptable pairs that we can get? The likelihood of you getting a pocket pair that is just aces is pretty small. But if I include kings in that, kings or aces, now my probability and the likelihood has increased some. To the point where by the time you get down to here, of a pair of 2s or higher, which means basically any pocket pair, we should see that that probability has increased as we've gone all the way down to here to whatever that is there. What is T? Tens. I'm not going to write 1010, I'm going to write TT. Okay? So tens and above. Okay, so now the question is, how do we compute the probability? And then in this chart you can see that I'm also calculating what I call ratio odds and also a percentage. So we're going to have to talk about ratio odds. We haven't talked about that yet. We have talked about probability, the likelihood that something is to occur. Okay, so good. We remember from the dice thing that to compute a probability, you need wins over ways. How many of the certain card is in the deck compared to how many cards are in the deck? So if I'm being dealt a hand of cards, first I get that first round of cards comes around and I get dealt an ace. What was the probability of me being dealt that ace? 4 over 52, because there's 4 aces in the deck. Those are my wins divided by the ways, which was 52. So I have 4 over 52 cards in the deck. Now I have an ace in my hand. The dealer is going to deal a round of cards again, and I'm going to get a second card. I need to get another ace in order to wind up with 2 aces in my hand, right? So what is the probability of me getting that ace on the second time around? Very good. It's 3 this time, because I already have 1 ace, which means there's 3 left in the deck. But because I know that one of the cards is no longer in the deck, it's not 52 cards left anymore, it's 51. So 3 over 51 is the probability for that second card. Now yesterday we learned about something called the fundamental counting principle. What is the fundamental counting principle? How do we use it? Yesterday when I asked you how many ways can you roll 2 6-sided dice, how did we use the fundamental counting principle? Yeah, there's 6 ways to roll one die and 6 ways to roll the other die. So if I multiply those two 6s together, I get 36 total ways to roll 2 dice. Okay? That's the fundamental counting principle. Basically, if I have an event, something happening, like rolling a die, that's called an event. And then I have another event, something else happening, like rolling a second die, that's another event. If I multiply the ways those two events can occur, I get the number of ways total that they can happen. And the same thing is going to be true here. I'm going to use the fundamental counting principle on these probabilities. I have a probability of 4 over 52 for getting that first ace. Once I have that first ace in my hand, even though there's a bunch of other cards already in play, I only know one of those cards in the deck, that ace that I have, which means there's still 3 aces in the deck as far as I'm concerned, but only 51 cards left in the deck. What I'm going to do is multiply those two numbers together. And I wind up with 12 over, what's 52 times 51? 2,652. That is a fraction that reduces. What is 12 divided by 2,652 going to reduce to? 1 over 221. There's your probability for being dealt ace-ace in Texas Hold'em. 1 over 221. What that means is you will get ace-ace one time every 221 hands. Is that going to happen very often then? No, not very often at all. So that's why people get excited when they get it, because it doesn't happen very often and it's a very powerful hand. Now, if you remember yesterday when we were talking about odds, when I showed you the craps table, you saw like 3:1 or 7:1 or 30:1. Okay, those were odds. So I want to calculate the ratio odds now. If I have one hand out of 221 hands being ace-ace, then that means how many of them were not ace-ace? 220. 220 hands were not ace-ace compared to one hand that was ace-ace. That's your ratio odds. It's the losers compared to the winners. There were 220 losers compared to one winner. And the percentage is simply dividing this fraction right here and getting a decimal and then moving the decimal 2 places to the right. So take 1 divided by 221 and give me the decimal. So you get, what was the decimal you got? 0.0045. Now if I make that a percent, that becomes 0.45%. So less than half of a percent of the time, you will get ace-ace as your starting hand. Which means for you guys who collected data, you dealt out 50 hands of poker. Statistically speaking, should you have seen ace-ace if you only dealt 50 hands? No, you could have, but it's not likely. And if you saw it, how many times should you have seen it? Probably just once, if you saw it at all. So I'd like you to take a look at your data and see if you actually did get ace-ace. No, not necessarily. It's not that you don't want to play. It's that you should play this hand when it comes up because it's very rare. It's a very powerful hand to start off with. Okay? You could win the hand with it. And most people usually do win the hand, but it is still possible to lose the hand even though you have that hand. So you can misplay the hand, and that's just from learning how to play poker. Okay? Now the important thing, there was actually 2 important things that happened here. First of all, this denominator in both cases. How many ways are there for me to deal you 2 cards? Well, the first time it goes around, how many cards are there in the deck? 52. It doesn't matter when you're calculating probability if you're the first person getting dealt a card or the 10th person getting dealt a card. It's still 52 possible cards in the deck for you because you don't know what those other cards were that people got. So it's still 52. How many ways are there for me to get that second card? 51. And the reason it's 51 now is because you have received that first card. You know what it is. You can look at it. Now when we go around again, whether you're the first person being dealt or the last person being dealt, there's still 51 cards that you don't know in that deck. And you're going to get one of them. And that's why it's 51 for that second card. If I was dealt a third card, it would be times 50. If I was dealt a fourth card, it would be times 49. If I was dealt a fifth card, like if we were playing 5-card draw, then it would be times 48. You'd multiply all those numbers together, and then you would know how many different ways I can deal you that many cards. So in this case, I have 52 times 51, which we found out was 2,652. So in the game of Texas Hold'em poker, there are only 2,652 possible starting hands, because you're only dealt 2 cards. That's a fairly low number considering the complexity of that game and the number of possible hands that you can have to finish. There's only 2,652 possible ways to start. Okay? Now this 2652 is going to come up again and again as we calculate these. So let's see if we can do the kings or aces. Kings or above. So if I want kings or aces on that first time around, how many cards in the deck help me get kings or aces? 8, that's right. Out of how many? 52. There's 8 cards in the deck this time. All 4 kings and all 4 aces out of 52 possible cards. Now once I have that first card, how many cards in the deck will give me that matching pair? No, it's not 7. It's 3. Because once you get that first card, it's either a king or an ace. Now there's only 3 of that card left in the deck for you to get to make the pair. Okay? So it's actually 3 out of 51. Okay, so we multiply that together, and what do we get? Okay, 24 over 2,652. And now we want to reduce that. So when that reduces, what does it give us? No, reduce it. 2 over 221. Okay, but that's not going to be good enough. When we're writing probabilities, we want it to be 1 over some sort of denominator. So we actually want to reduce that to be 1 over something. And the way that you're going to do that is by taking this and actually doing that division. So do 2 divided by 221. I got that. I said that backwards. I'm sorry. You're going to take this denominator and divide by the numerator. What is 221 divided by 2? 110.5. By doing that, that is going to turn my numerator into a 1 and my denominator into 110.5. That is the correct probability for being dealt kings or aces. So better? What's that? Kings? Absolutely. People get really excited when they see kings. Yes? Chances are better. This is including aces and kings. Because what's the probability of being dealt specifically kings? The same as being dealt specifically aces. Yeah, we're talking about a specific pair here, okay? It happens to be aces. But if I wanted specifically 7s, it's going to be the same exact probability. It just so happens that we're talking about aces because that's the highest pair in the deck. But if you want any specific pair, it has the same probability here. So now, if I'm being dealt any of these 2 specific pairs, this is my probability. 1 hand out of every 110.5 hands will be kings or aces, statistically speaking. So what would my ratio odds be then? If 1 hand in 110.5 hands is kings or aces, 109.5 losers compared to 1 winner. Basically, you subtract the numerator from the denominator. Okay, what is the percentage likelihood that you'll see kings or aces? Go back over here and just evaluate that, or you could go back to this and just give me a decimal version of that. Move the decimal 2 places over to the right, and what do you get? 0.9. What's the next decimal? 0.05, so 0.91% of the time. Still less than 1% of the time. So less than 1% of the hands that you play, you will be dealt aces or kings to start. So let's take a look back at our data and see. We have 400 starting hands here. How many would we expect to see be kings or aces? Less than 1% of the time. So we're expecting about 4 hands, kings or aces, or less. 4 or less is what we're expecting. So let's see what we got. We got 2 instead of 4. No big deal. Still very statistically close to what we were expecting to see according to the theory. This, by the way, is the theory, theoretical probability. You have an experimental result, an experimental probability. They should be fairly close to each other. Queens. What's the probability of being dealt something that gives me queens, kings, or aces in that first card? Now there's 12 cards that work over 52. And once I have that first card, there's only 3 left in the deck that make me a pair, so 3 over 51. Multiply those together. 36 over 2652, that reduces down to what? 3 over 121. And we want to make that actually just 1 over something. So you go, sorry, 221? Is it 221? $73.6. So this turns into 1 over 73.6. So every 73 or 74 hands, you should see queens, kings, or aces show up in your, as a pocket pair, okay, in your hand. Let me finish off the line here. What would my ratio odds be then? 72.6 losers to 1 winner. And what is my percentage? 1.35% of the time. Okay? I'm actually trusting you on that one. I don't know that one for sure. Okay, so that's the idea. All right, let's do one more here, the jacks, and then I'll let you guys come up with the probabilities for the rest. 2 jacks or better as your starting hand. So what am I dealing with for my first card? 16 out of 52. And what am I dealing with for my second card once I get that first card? 3 out of 51. Whether it's a jack or a queen or a king or an ace, there's only 3 left in the deck that give me that pair. So we need to reduce that fraction down and write it as a numerator of 1 over the denominator. So what do we get? 1 over what? 55.25? Okay, so there is our probability. What's the ratio? 54.25 losers for every 1 winner. And what is the percentage there? 1.81% of the time you should see jacks or better as a starting hand. Now, we've already talked about jacks. Nobody saw jacks, right? Or was there 1? You have 2 jacks? Okay, so we were at 2 aces, kings, and queens. We have 2 more jacks, so now we're at 4 hands that look like that. Does anybody else have a pair of jacks in their data? We're at 1.81%, which out of 400 hands would be 4, like around 4 or 5, maybe 6 or 7 even. Jacks are better, and right now we're at 4. So we're kind of still within that window, no big deal. All right, I'd like you to take some time and calculate the probability, ratio odds, and percentage for 10s all the way down to 2s, and then we'll fill in the rest of this table. So for 10s, we have 1 over 44.2, which makes my ratio odds 43.2 to 1. 43.2 losers to 1 winner. And then my percentage for that one was 2.26%. Good. How about 9s?
1 over 27.1. The ratio is 26.1.
I'm going to stop you there.
So,
For 9s, how many cards can I get dealt first?
24.
We have 9s, 10s, jacks, queens, kings, aces. That's 6 of them, right? Times 4 cards for each of those ranks, 24. So 24 over 52 times 3 over 51. Enter that into your calculator. Divide the denominator by the numerator.
72 over 3.1.
Okay, divide the denominator by the numerator.
6 over 3.1.
Right, divide the denominator by the numerator. What'd you get?
1 over 27.1.
36.8. Right? Yeah. So it should be 1 over 36.8, which makes my ratio odds 35.8 losers to 1 winner, which makes my percentage 2.71% of the time. All right, 8s. So 1 over 31.6, we'll call it. Okay.
And then the ratio would give me
30.6 losers to 1 winner.
and a percentage of
3.17% of the time. Good. And 7s.
I got 1 over 27.6.
1 over 27.6 is good. Good.
And 3.6%.
3.62, we'll say. Correct. Very good. And where are we at? 6s.
I got 1 over 24.5.
So we'll call that 1 over 24.6. So it'll be 23.6 losers for every 1 winner. And then the percent? And 4.07 is good enough, percent. Very good. And 5s.
I got
1 over 22.1 is good.
1
Correct. 4.52%. Okay, and somebody with 4s or better. Remember, this is always the pair and every higher pair than the one that we're looking at. So this is 4s or better in your hand. So 4s, 5, 6, 7, 8, 9, 10, jack, queen, king, or ace in your hand. So we'll call that 1 over 20.1. 19.1 to 1. So let's do 1 divided by 20.1. What do you get? 4.9, if I round it, 4.98%. Okay, and 3s, somebody else.
over
1 over 18.4, we'll say. 17.4 to 1. 5.43% is absolutely correct. All right, so 2s or better. And notice that I said that means any pair. So right now what we're doing is we're calculating the probability that when you look at your 2 cards that you're dealt in Texas Hold'em, you will look down at a pair, no matter what the pair is. All right? So what is this one? I mean, what is the probability? Yeah, because any card, 52 over 52, works, right? But once you get that first card, by the way, what is 52 over 52? 1. Once you get that first card, the next card has to be 3 over 51, which reduces down to what? 1 over 17. The ratio odds then would be 16 to 1. And the percentage of that is 5.88%. So, every 17 hands that you're dealt, you should see a pair. And now what I want to do is take your data and count up all of the pairs that you got. Any pair at all. How many pairs total should we find? Whatever 5.88% of 400 is, because that's how many hands we had dealt. So count up your pairs. We counted up all of our pocket pairs, and we wound up with 24 pocket pairs. We're expecting to see 5.88% of the time we get a pocket pair. We had 400 hands dealt. Well, 5.88% is roughly half of 10%. 10% of 400 hands dealt would be how many hands? How many? 40. So if we're talking about 5% though, 5% would be more like 20. But it's not 5%, it's more like 6%. So we could expect to see probably somewhere around 22, 23, 24, 25 hands. Actually, if you calculate out, it's 23.52 hands we would expect to see that give us a pocket pair. And we came up with, in our data collection, 24 hands that had a pocket pair. Pretty dang close to the expected theoretical result from the numbers. Our experiment was actually dead on. You can't get any closer than that. So this is probably the best I've ever seen as far as results goes in the end for pocket pairs. So just to show you that these are the official probabilities for each of those hands. I did have them on the next slide, but they are here, and you guys came up with these exactly on your own. So you are capable of doing this. If you ever watch Hold'em on TV and they give you a percentage, or they start talking about probability or odds or something like that, these are the numbers that they're talking about. Once you get to that point of understanding a table like this and you watch poker, you know exactly what those people are doing. The people who are on TV, who are successful, basically have this memorized, and they know when a hand is good or not. But pairs aren't the only hands you can get dealt. There's lots of other types of hands that people really like to play in Texas Hold'em as a starting hand. So, these are other starting hands. We're going to compute the probability, the ratio odds, and the percentage for each of those as well. So what does AK mean? Ace King. The probability that you're dealt Ace King. Any compared to Ace King suited means any Ace King will do here. But this one has to be specifically suited, meaning that my ace and my king are both clubs, for example. But maybe my Ace King any is like an ace of hearts and the king of diamonds. So we want to calculate the probability of any Ace King. How many cards in the deck allow me to get that hand started? 8 out of 52. There's 8 cards in the deck that give me an ace or a king on that first one. But once I have that first card, how many cards are there left in the deck to give me that completed hand, Ace King? That would give me a pair. Actually, it's 4. That's right. So let's say I got my first card and it was a king. What do I have to get now to make Ace King? No, because that would give me King King, and that's not what I'm looking for here. I need Ace King. I got Delta King, so what do I need? I need an ace. How many aces are left in the deck? There's 4. Out of how many cards left in the deck? 51. So it's going to be 4 over 51. 8 cards could get me started, but once I got that first one, 4 cards complete that hand. So now we need to divide, multiply those two things together, and divide so that we wind up with 1 over what? Well, you reduce the fraction down to a 1 over. What's the denominator going to be? Eight times 4 is 32. 52 times 51 is 2652. But I got to reduce that so that it's 1 over something. No. We're not off. So I'll bring up my calculator. I have 8 times 4, which is 32, and then 52 times 51, which is 2,652. So I take that number and I divide it by the 32, and I'm pressing Control-Enter to give me the decimal. It's 82.875. So in other words, 82.9. There's your probability. So 1 out of every about 83 hands should be ace-king. Any ace-king. The ratio odds then would be, and the percentage, $1.2? There you go. So, what I need you guys to do is come up with the rest of these. Hopefully by now you've copied down this table. We'll call that homework for tonight. We will calculate the probability, the ratio odds, and the percentage of these. So what do these mean? Ace-king suited means the two cards have to have the exact same suit. Any two cards that are suited means my first card is one suit, but then my second card has to be that same suit. Any two cards connected. Connected cards are like 6-7 or Jack Queen. Okay? So you have to think about that one a little bit. Suited and connected means they have the same suit and they're connected like 6-7 or Jack Queen. And then any specific hand. Pick your favorite hand that you ever thought of before. My favorite hand that I love to hate is 6-2 because I seem to get it all the time. So pick your favorite hand. That's your homework.